Some of Saturn's icy moons as well as its famous rings might be modern adornments, and their dramatic birth may have taken place a mere 100 million years ago, more recent than the reign of many dinosaurs, a new study suggests. Moons are always changing their orbits. That is inevitable. But the fact allows us to use computer simulations to tease out the history of Saturn's inner moons, said Matija Cook from the Search for Extraterrestrial Intelligence study in the U.S. Doing so, we find that they were most likely born during the most recent 2% of the planet's history, said Cook. Cook, along with researchers from the Southwest Research Institute, used computer modeling to infer the past dynamic behavior of Saturn's icy inner moons. While our own moon has its orbit around Earth to itself, Saturn's many satellites have to share space with each other. All of their orbits slowly grow due to tidal effects, but at different rates, researchers said. This results in pairs of moons occasionally entering so-called orbital resonances. These occur when one moon's orbital period is a simple fraction, for example, 1/2 or 2/3 of another moon's period, they said. In these special configurations, even small moons with weak gravity can strongly affect each other's orbits, making them more elongated and tilting them out of their original orbital plane, researchers said. By comparing present orbital tilts and those predicted by computer simulations, researchers could learn how much the orbits of Saturn's moons grew. For some of the most important satellites, Titan, Dione and Rhea, the orbits are less dramatically altered than previously thought, they said. The relatively small orbital tilts indicate that they have not crossed many orbital resonances, meaning that they must have formed not far from where they are now. To find out how long ago was their birth, researchers used results from NASA's Cassini mission to help answer this question. The Cassini spacecraft has observed ice geysers on Saturn's moon Enceladus. Assuming that the energy powering these geysers comes directly from tidal interactions, and that Enceladus' level of geothermal activity is more or less constant, then the tides within Saturn are quite strong. According to the team's analysis, these would move the satellite by the small amount indicated by the simulations in only about 100 million years. This would date to the formation of the major moons of Saturn, with the exception of more distant Titan and Hypatia, to the relatively recent Cretaceous period, the era of the dinosaurs. The findings were published in the Astrophysical Journal.